Alrighty. What's up, everybody? Hope you all having a good night. I wanted to live stream today because I need to create more content. That's something I've been struggling with a little bit, and I want to get better at it. So here's me streaming, and here's me trying to do more of that. So right now I'm going through the Electron tutorial, and I just wanted to make a video later today talking about my experience with it and seeing how fast I can make an app, learning through this, and then learning through actual AI. So let's see how it goes. Also, I want to see my chat, which I cannot see right now. Chat. All right. So my chat is up. All right. It is 7:34 right now. We're probably going to stop streaming around 8:30 or so. Let's do it. So right now, the first thing that I did was just follow this tutorial. And I'm going to add this into here. Let's see. Where was I? The create window function loads your web page into a new browser instance. Yeah, so here I made a new web page. Also, I'm pretty sure I could just rename this to .getignore, right? Okay. So I have a new web page over here. Where is my index.html? Which is just like a hello from Electron. And this is how I instantiate that new web page. I do const window new browser window. And the width and height of that is this by this. I wonder what is default and height. Server banner size? Yeah, I don't remember that. I guess Discord is usually just full screen, right? Oh, I just did Control R and reset everything, huh? Okay. All right. And then this load file is this. This is this. Many of Electron's core modules are Node.js event emitters that adhere to Node's asynchronous event-driven architecture. The app module is one of these emitters. In Electron, browser windows can only be created after the app's module ready event is fired. You can wait for the event using the app when ready, so this tool, API, and calling create window once its promise is fulfilled. You typically listen to Node.js events by using an emitters.on function. However, Electron exposes app when ready as a helper especially for the ready event to avoid subtle pitfalls when directly listening to that event in particular. Okay, so maybe it's like when you close it out, something explicit happens. So you open page. Each web page your app displays in a window that will run a separate process called the render process. Render process have access to the same JavaScript APIs and toolings that you use for typical front-end window development, such as Webpack bundle and minify your code or React to build your user interfaces. Managing your app's window lifecycle. Application windows behave differently on each operating system. Rather than enforce these conventions by default, Electron gives you the choice to implement them in your code, in your app code if you wish to follow them. You can implement basic window conventions by listening for events emitted by the app and browser window modules. Checking against Node's process platform variable can help you run code conditionally in certain platforms. 3 possible platforms. Okay, so Linux and Mac. Okay, sweet. Quit the app when all windows are closed. On Windows and Linux, closing all windows will generally will generally quit an application entirely. Yeah, that makes sense. To implement this pattern in your Electron app, listen to the app's module Windows all closed event and call app quit to exit your app if the user is not on Mac OS. All right, well, let's add that, I guess, to our name. App.on. This is Windows all closed. If process.platform equals Darwin, app.quit. Whoop. Dot quit. Why is this an open bracket? Man, something with these the autofill is that if it doesn't work, it's very annoying, but when it does work, it's perfect. So app.on, window all closed. If process.platform does not equal Darwin, oh, quit. Even without any windows. Okay, so now this will work on Windows and Mac. Sweet, I guess. Hmm. I wonder why they did it this way. Const app browser window equals require Electron. Const create window. Also, dot when ready is in this. What is going on? App dot when ready. What is wrong with my function right now? I feel like this should all be tabbed out one. sure. I know I'm getting texts. All right, so what was the difference between this one and this one? Uh, split right. Hmm. Activate if all, is it saying if all other windows are closed, then create a window? All right, excuse me. Getting back to it. If you want to debug your application using VS Code, you need to attach a VS Code to both main and renderer processes. Here's a sample configuration for you to run. Create a launch.json configuration. Let's see, new file, launch.json. Hmm. I'm just going to copy this and put this here. And then ask, is my correct for okay, sweet. You will learn what a preload script is and how to use one securely to expose privilege. Privilege APIs into the renderer process. You will also learn how to communicate between main and renderer processes with Electron's inter-process communication modules. Process is a Node.js environment that has full operating system access. Type of Electron modules, you can also add Node.js built-ins, as well as any packages installed via npm. On the other hand, renderer processes run web pages and do not run Node.js by default for security reasons. To bridge Electron's different process types together, we will run a special script called the preload, augmenting the render with the preload script. A browser window's preload script runs in a context that has access to both the HTML DOM and a limited subset of Node.js and Electron APIs. From Electron 20 onwards, preload scripts are sandboxed by default and no longer have access to a full Node.js environment. Practically, this means that you'll have a polyfilled require function that only has access to a limited set of APIs. Explain what this means. Preload scripts run in the renderer process for the web page. They bridge the main process and the renderer web page. They can expose safe AIs, context bridge, set up communication. Polyfilled. What does polyfilled mean? Code that provides functionality that may be missing in a given environment. It mimics the API behavior code so code can run without changes, even if the real implementation isn't available. The name comes from Polyfilla, a UK brand of spackling paste, and it fills gaps. It doesn't exist in the older browser. Oh, okay, well, I guess it's just like a placeholder. Cool. Preload scripts are injected before a web page loads in the renderer, similar to Chrome's extension content scripts. To add features to your renderer that require privilege access, you can define global objects through the Context Bridge API. Okay. To demonstrate this concept, you will create a preload script that exposes your app's version of Chrome, Node, and Electron to the renderer. Add a new preload.js script that exposes selected properties of Electron's process.versions object to the render process in a versions global variable. Preload.js. So this shows what version I'm on, I guess. Yeah. To attach the script to your renderer process, pass its path to the web preferences preload option in the browser window constructor. Okay, so this is the constructor over here. Go back to here, here, here. And I gotta add extra one of these there. Web preferences here. Okay, so now if I do npm run start, I should see. Oh, I need to. At this point, There are two Node.js concepts that are used here. The dir name string points to the path of, let me actually change my name. How do I manage my live stream? Uh, Here we go. Building. Points to the path of the currently executing script, in this case your project's root folder. Path.join API joins multiple path segments together, creating a combined path string that works across all platforms. At this point, the renderer has access to the versions global, so let's display that information in the window. This variable can be accessed via the windows.versions or simply versions. Create a renderer.js script that uses the document.getElementID DOM API to replace the displayed text for the HTML element with its info as ID property. Okay, so now I'm going to make a renderer.js. Render.js, and then I'm just going to have this. This app is using Chrome and Electron, and it'll actually pass in that information over here. So now I got to go to my HTML, and I got to say, just in the actual body, PID info. Let's see what that looks like. I'm just going to assume, or let me see, yeah. Does that call the script? I don't know. Let's see. PID equals info, script source, and let's do npm run start. Path is not defined. So I think it's this one. I think that's broken. Oh, I guess I have to put it into the body. So I guess when I'm running a script, it has to be outside of the actual body. Okay, cool. see it now. We can do npm run start. Path is not defined. At create window. Was that a new one? Okay, so wow, I really got to be careful with the way that I write everything. So I can't have the software is so interconnected in terms of how I pass one script to another. But it's nice that everything is so like modular. I know this is still a tutorial and this is how most modern software works, but it's cool actually walking through this and seeing how it all works out. At this point, the renderer has access to versions global, so let's display that information. Yep, we're displaying it right now. Okay, the code should look something like this. Yep. Okay, Electron's main and renderer processes have distinct responsibilities and are not interchangeable. This means it is not possible to have access to the Node.js APIs directly from the renderer process, nor the HTML document object model for the main process. The solution for this problem is using Electron's IPC main and IPC renderer modules for inter-process communication. To send a message from your web page to the main process, you can set up a main process handler with IPC main.handle and then expose a function that calls IPC renderer.invoke to build a trigger handler in your preload script. To illustrate, we will add a global function to the renderer called ping that will return a string from the main process. First, let's set up the invoke call to your preload script. Okay, so what am I doing right now? I am just trying to show that to communicate between the processors because there's different responsibilities for the rendering and the actual main process. So if we go to our preload.js, we're going to add this IPC renderer. Then we're going to call it in over here. Bing equals IPC renderer.invoke ping. Notice how we wrap IPC render ping call in a helper function rather than expose the IPC renderer module directly via the context bridge. You never want to directly expose the entire IPC renderer module via preload. This would give your renderer the ability to send arbitrary IPC messages to the main process, which becomes a powerful attack vector for malicious code. I don't really understand this. Can you explain this a little bit more? Right, then set up your handle listener. My eyes are burning. I have my f.lux on. Const context bridge. This is main.js. Main.js. Huh? Oh man, my eyes are burning. All right, I'm back. Sorry, I just put some eye drops in. My eyes are burning a little bit. Grab tissue. Programming in the dark. It's getting a little. Getting a little. What's it called here? Getting a little steamy in here. It's getting dark. Const app browser window. Now I got to the IPC main. Require Electron slash main main, and then add in this here after the win.load file. Ping equals pong. Huh? Once you have the sender and receiver set up, send messages from the render. The main process is ping. Ping and pong? Bro, this is crazy. Render.js. Once you have the main sender and receiver, you can now send messages from the render to the main process through the ping channel you just defined. All right, I got to define this function, and I think I got to add it right underneath here, right? So const func asynchronous const responsive wait window console log. Okay, and it calls the function again. A preload script contains preload script contains code that runs before your web page is loaded into the browser window. It has access to both DOM APIs and a Node.js environment. Node.js environment. It is often used to expose privileged APIs to the renderer via the context bridge API. Because the main and render processes have very different responsibilities, Electron apps often use the preload script to set up inter-process communication (IPC) interfaces to pass arbitrary messages between two kinds of processes. In the next part of the tutorial, we will be showing you resources on adding more functionality to your app, then teaching you how to distribute the app to your users. Awesome, that's what I want to learn. So let's do npm run start, and let's see if it console logs the ping pong. Let's see. Why? How can I visualize the ping in the bong sending from my renderer? No, I don't need that. Okay, that's how it works. Therefore, Electron's doc will not go in depth how to use standard web tools. On the other hand, Electron also provides a rich set of tools that allow you to integrate with the desktop environment, from creating tray icons to adding global shortcuts to displaying native menus. It also gives you all the power of a Node.js environment in the main process. This set of capabilities separates Electron applications from running a website in a browser tab and a focus on Electron's documentation. Electron's documentation has many tutorials to help you with more advanced topics and operating system integrations. To get started, check out the how-to examples doc. What's next? For the rest of the tutorial, we're shifting away from the application code and giving you a look how you can get your app from your development machine into the end user's hands. Yes, I want to see that. In this tutorial, we're going off the basic packaging and shipping Uniac with the Electron Forge. This is Electron Forge. Electron does not have tooling for packaging and distribution bundled into its core modules. Once you have a working Electron app in dev mode, you need to use additional tooling to create a packaged app you can distribute to your users, also known as distributable. Distributables can either be installers, MSI on Windows, or portable executable files like a .app on macOS. Electron Forge is an all-in-one tool that handles the packaging and distribution of Electron apps. Under the hood, it combines a lot of existing Electron tools into a single interface so you don't have to worry about wiring all together. You can install Electron Forge CLI on your project's dev dependencies and import your existing project with this handy conversion script. Okay. I just did that. Low severity vulnerabilities. Once the conversion script is done, Forge should have added a few scripts to your package.json file. Scripts. Looks like it didn't. I just have this. Oh. There we go. Whoa. Why did I get this error? Oh. Sweet. Woo 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 woo. Oh woo 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 woo. You should also notice that your package.json has more packages uninstalled dead dependencies, and a new forge.config that exports a configuration object. You should see multiple marker makers packages that generate distributed app bundles in the pre-populated configuration, one for each target platform. Creating a distributable. Use your project's new make script, which runs the Electron Forge make command. Okay. A squirrel distributable. A squirrel. What is this? A squirrel distributable. Huh. This takes a little bit of time. After the script runs, you should see an out folder. Wait, let me read this. This make command contains two steps. It will first run Electron Forge package under the hood, which bundles your app code together with the Electron binary. The package code is generated into a folder. It will then use this packaged app folder to create a separable distribution for each configured maker. After the script runs, you should see an out folder containing both the distributable and a folder containing the package application code. Out. This be ready to launch. Let's launch that. Let's launch that. Shh. How do I launch it? No, wait. I just want to open. Wow. I forgot to delete that. Hey. What does that button do? I have no clue. Hello. Hello. Alright, I guess we'll worry about that later. Alright. All good. All good. All right, what's the next step? Here. In order to distribute desktop applications to end users, highly recommend you code sign in your Electron app. Code signing is an important part of shipping desktop applications and is mandatory for the auto update step in the final part of the tutorial. Code signing is a security technology that uses to certify that a desktop app was created by a known source. Windows and Mac OS have their own OS-specific code signing systems that will make it difficult for users to download or launch unsigned applications. On Mac OS, code signing is done with packaging level. On Windows, distributed installers are signed instead. If you already have the code signing, uh, yeah. Electron application need to be packaged and distributed to end users. In this tutorial, you imported your app into Electron Forge and configured it to a package in your app and generate installers. In order for your application to be trusted by the user system, you need to digitally certify the distributed as authentic and untampered by the code signing it. Your app can be signed through Forge once you configure it to use your code signing certificate information. Okay, sweet. If you've been following along, this is the last step of the tutorial part, and you publish your app to GitHub releases and integrate automatic updates into your app via code using update electron.js.org. The Electron maintainers prefer to via auto updating services for open source apps that update requirements are your app runs on Mac OS Windows. GitHub repository, build or publish to GitHub releases, build your code sign. Push your code. I have not done that. CD. Or just do a git a git commit am initial code and do a little bit of a git push. Oh, I guess I pressed shift on accident. Git push main. Does that work? Yes, it did. Oh yeah. Oh, it's called master. Can't be saying that stuff anymore in 2025. All right, we got this on GitHub. Electron forces the publisher plugins that can automate the distribution of your package application to various sources. In this tutorial, we're using GitHub Publisher. We'll also publish our code to GitHub releases. Generating a personal access token. Forge cannot publish to any repository on GitHub without permission. You need to pass in an authenticated token that gives Forge access to your GitHub releases. The easiest to do this is to create a new personal access token within the public repo scope, which gives. Make sure to keep the token as a secret. Uh-oh. Let me change that. Let me make sure that you guys can't see that. Installing the module. I think I already have this, right? Paste it. Oh no, I need the GitHub publisher now. Once you have it installed, you need to set up your Forge configuration, a full list of options. Okay, yeah. So, in my Forge, I should see something. Repository. No, I gotta add this publisher's name. Yeah, I really. My neighbor's dog is barking. Owner, GitHub username. I think that's what I call it. How does it know that? I have no idea. Oh. Now in my package.json, I have a friend named Jason. Make them publish. Electron forge.publish main. This command will render configured makers and publish out distributables. npm run publish. Am I doing it right? I'm making a squirrel distributable. A squirrel. Yes. Ready. All right, let's not worry about that. By default, you only publish a single distributable with your host operating system architecture. You can publish your different architectures by passing in this thing over here. Code. Now that we have functional release, you need to tell her after download update whenever new release is out. Electron apps do this via auto updater module, which reads from an update server feed to check if a new version is available to update. The update allow Electron service provides an update compatible via. For example, we'll check out the endpoint to see if new GitHub release action. After release publish GitHub the update should work for your application. The only step left is configure the feed with auto updater module to make the process easier. The team maintains the update Electron app module, which sets up the auto updater boilerplate for the update Electron JS in one function call. No configuration required. This module will search for the update Electron JS to feed. Okay. You got it. You got it. Oh yeah. Import the module and call it immediately in the main process. I'm calling it. Hello. Where do I put this? Require update Electron app. That probably comes at the top, right? Okay, so once your application is packaged, it'll update itself for each new GitHub release that you publish. In this tutorial, we configure Electron for GitHub Publisher update at distributed GitHub releases. The distributed shows cannot always be generated between platforms. Recommend setting up your building your publishing flow in a contiguous integration pipeline if you don't have access to machines. Electron application sets self-update by pointing the auto updater module to an update server feed. Update electron.js.org is a free update server provided by Electron for open source publications. Yeah. If your application is not eligible for update Electron, you should instead deploy your own update server and do that. Okay, sweet. I'll do that next time. Electron enhances most of the processor Chromium, which makes the framework architecture very similar to modern web browser. This guide will explain the concepts applied in the tutorial. Why not a single process? Web browsers are clinically complicated applications. Aside from their primary ability to display web content, they also have many secondary responsibilities, such as managing multiple windows or tabs and loading third-party extensions. In the earlier days, browsers usually used a single process for all of this functionality. Although this pattern meant less overhead for each tab that you had open, it also meant that one website crashing or hanging would affect the entire browser. The multi-process model. To solve this problem, the Chrome team decided that each tab would render its own process, limiting the harm that buggy or malicious code on a web page could cause to the app as a whole. A single browser process then controls these processes, as well as the application lifecycle as a whole. This diagram below from the Chrome Cosmic Visualizer visualizes this model. Let's see, make it large. Google Chrome. Today, most of what we use the web for on a day-to-day basis aren't just web pages, they're applications. People are watching and uploading videos, chatting with each other, playing web-based games, all these things that didn't exist when browsers were created. Pam Green, software engineer. Wouldn't it be so great to start from scratch and design something based off the needs of today's web applications and users? Maybe. This is a comic. This is actually pretty sick. First, browsers need to be stable. When writing an important email or editing a document, a browser crash is a big deal. Browsers also need to be faster. They need to start faster, load pages faster. And for apps, JavaScript itself can be a lot faster. They need to be more secure, given what we know about mass browser exports. Browsers need to be architectural changes to disadvantage malware. And we want browsers to find that sweet spot between too many features and too few, with a clean, simple, and efficient user interface. Ben Goodger. Finally, Google Chrome is a full open source browser. We want others to adopt ideas from us, just as we adopted good ideas from others. When we first started the project, the Gears guys were saying that one of the problems with browsers is that they're inherently single-threaded. This is so interesting. So developers write APIs that are asynchronous. And now browser likes to hung up on something. Gear shows the multi-threaded browser. As soon as I finish this comic, I will have to probably turn off the stream. This is a 40-page comic. Okay, that's fine. But yeah, I said that I was going to program for an hour, and I programmed for an hour. That's about it from you guys. Thank you so much for watching. This is probably going to be a video, so I hope to see you guys later. Peace.